Alright, so we're going to take these same polynomials we've been working with. And we're going to do the same thing that we did in chapter 1. Okay? Remember when we were factoring in chapter 1, we would have something like this. And the key was we had to make sure that it equaled 0 first. Always make equal 0. I'll give you all a second to get. All right, so whenever we factored and solved, we would factor this side. What are two things that multiply to 6 but add to 5 with the same sign?
2 and 3.
2 and 3.
We did this.
This is just a recap. We did do it a little bit yesterday. Reviewing you again today on it because it's going to tie into what we're doing today. GCF? 1 what? X. GCF? 3. GCF? 1 what? GCF? 2. Why doesn't that one get an X? 6 don't have an X to give. Alright, so I've got X plus 3, and I'm running kind of quickly through this one because this one is review. And now what did we do at this point? Once we got it factored, what did we do? Let's see if we can break it down and then put each piece to 0, right? Both of you are right. So I can't break it down any further, so I'm just going to set each piece equal to 0. Does anybody remember what that property was called?
Yeah.
Make it equal 0. It was called the zero product property. If two or more things are multiplied together to give you 0, then one or more of them must be 0 to make the equation true. Okay. And so we got 2 answers. So we're going to apply that same concept today, but now we're factoring in some different ways, okay? So it's just going to make us have a little bit more complex answers, but it's the same thing. Y'all ready? We did already do this a little bit, yeah. So I think the easiest thing to do is to show you by example because we've factored so much. So let's look. 4x to the 5th minus 40x cubed
This is new stuff, right?
plus 36x equals 0, yeah. And it's not really new. We're going to approach it the same way, okay? So we're still, okay. We go through this. Remember our steps. The first thing we want to do is make sure it equals 0. Then we're going to check for GCF. Huh? Yes, you're absolutely right. Then we're going to check for, and I'm just going to write these steps out so we can go through them as we work through this problem. Check for a special pattern. Can we put it in the box? And then we're going to solve lastly. Does it equal 0? Yes, I'm good on that. Do I have a GCF I can take out? 4x. So let's take it out. What's left?
It's going to be 4x, x, right?
X to the what?
8. Second.
Yeah. Oh my gosh.
How are you getting 4? That's a 5.
How are you getting 8, 2, 7, all these other numbers?
I did the exponent 5 plus 3 equals 8. 5 minus 3 equals 2.
All right, we took an X away from everybody. So if it had 5 and you took one away, how many X's are left?
You would have 0. I don't know why you would have 4.
If you got 5 apples and I take an apple away from you, how many apples do you have
But
left?
how is 6? 4x, okay? If you take, I don't even know where I'm going with this. I don't even know what you did. But if you divide 4 by everything, it's 4x on the outside. I get that. But how are you getting x 4? You just took that out.
I took one X out. It had 5. Somebody help me explain it to them.
overthinking. Look, if you have 4x there, you take one out from the 4x5, the 4x3, and 36 there. You just subtract an x from each one. You took one out.
Well, if I'm gonna subtract x from each one from 5, x5, it's gonna be 2.
No, it's not.
No.
If
Where
you take
you
one
get
x,
4?
if
That's
you take
what
one
I'm-
x from a 5, it's 4. That's what you got the 4 from.
So if it was 6 right there, I'd take that out and it'd be 5.
Yes.
Yes. There's 3 would be 2.
So I ain't gotta worry about all the other ones.
No, you still do. You take one
We
x out
do,
from
we
each one.
stopped here because you didn't understand where we got
But
4
I'm not
from.
worried about the other ones. I'm gonna just, when I minus that 4x, if it was 12 up top x one, it'd just be 11.
Yes.
Yes.
Alright, then that's all you have.
Okay, so look at the middle one.
What's the middle one, right?
What's the middle term gonna be?
Alright, the middle is gonna be, if I divide that, that's gonna be 10.
That's gonna be 10.
X squared.
Don't tell him.
No, it's gonna be 10x to the third.
Oh, no. See,
Oh, no.
I'm taking 4x1 out of each one.
So how many's left?
So it'll be 2.
There you go.
Alright, then the next one just be 36.
That would be 9.
It's not gonna be
You gotta
9.
divide 4 and 4x.
Yeah, so it'll be just be 9.
That's right.
Alright,
He wants to argue with it, and then we realize.
All right,
hold up.
that's step 2.
That's step.
Dang, we on step 2. We've been on it for at least 5 minutes.
You don't necessarily do each step. It's kind of a brain process you go
No
through.
special patterns. I know that much.
All right, look what's in parentheses. Do you see any special patterns?
Yeah, they even. Have
So we're gonna use the box because it's quadratic form, right? All right.
What's the special pattern you got?
This one is quadratic form. I'm telling you, quadratic form.
But what's the special pattern?
Quadratic form.
It's not a pattern.
Yeah, it is, dude. Even 4.
Even,
Half,
half, constant. All right, signs are the same. They're both negative. What multiplies to 9 but adds to 10?
9 and 1.
9 and 1. They're squared because they're whatever's on the middle. So 9x squared and 1x squared.
Why you putting squares? You need to put squares on something.
See that number that's in the middle? See that term that's in the middle?
He's got a square.
If it's got a square, the square goes in the box.
Alright.
Whatever's that middle is what goes in the box. All right, GCF
X.
squared.
How's that square? What
Because
about
there's
4?
you can take 2 x's out of each one.
Alright, Brad, you need to.
Okay, then Brady, you just address this question from now on. Okay, GCF.
It'd be 9.
No, it's
1.
just x.
It's
Or
just
1,
X.
1, not x.
1.
My
You
bad.
don't know.
No, my bad. I was
All right, go across
X squared.
good.
and across.
1. 9.
What are the signs gonna be?
Wait, what was the top one? 1.
1.
Mine.
Minus, minus. So I've got x squared minus 1, x squared minus 9 equals 0. I'm still on special patterns.
Hold up, no, man.
X, you can do x plus 3 and x minus 3.
Why, Brady?
Because negative 9, or 3 times 3 is 9.
Those are, what's that called?
Dividing.
Difference of two
Yeah,
squares.
squares.
And actually, both of these are difference of two squares because one's a perfect square too.
X, so it'd be X minus 3 and X plus 3.
What about the x squared minus 1, Bryce?
X plus,
You can't do nothing with that.
x plus 1, x plus.
Why do you have both of them negative?
Oh, no.
Why you got both negative?
Because, I'm getting to her, I had to finish my thought there.
Minus plus.
Because minus plus gives you minus minus when you factor. Alright, so do you see any other factoring in that problem that I can do? Is it factored absolutely completely?
Yes.
So at this point, I don't need the box or anything else, I'm ready to solve.
That's not solid.
So when you solve, all you have to do is set each piece to 0 and solve. Each piece.
Like 4x equals 0 also?
So 4x equals 0. X plus 1 equals 0. X minus 1 equals
We gotta
0.
solve for all these.
Mhm.
There's just gonna be a lot of writing.
Yeah, it's not hard though. It's what we were doing yesterday.
Alright, I got all this BS down, now what?
You got each one to 0?
Yep.
Alright, so if I divide by 4,
Wait, am I supposed to do 0 equals 0?
no. So x equals, subtract 1, add 1, add 3, subtract 3.
So it wasn't like
Whew.
actually used, but now we have all of our X.
Yeah, we do, if you do it right.
I got 2 more to do with you.
2 more. I told you.
Well, that's all homework
then.
then. These three will be our homework.
What do you do first?
Gotta
Hold up, let me
14.
write that down.
Or subtract 14.
Be sure to see
Subtract 14, make it equal 0, exactly. So if I move 14x cubed, and I don't want anybody to get confused when I move this, but I'm going to put it in the middle. And the reason I'm going to put it in the middle,
So it's gonna be 2x5 minus 14x.
yes.
Alright.
I want it to be in the right order. GCF, do I have one?
Yeah,
You gotta
2
slow
what?
down now,
Okay,
you're
okay,
walking
okay,
fast.
okay. So 2 what?
2x.
X. What's left?
How did you get
X.
2x?
Because you divide 2x.
By everything.
Yes,
Yeah,
because you can
Somebody said x to the 4th, that's right, minus.
7x squared
Yeah, just 1.
plus 12.
You're absolutely right, Bryce. It's quadratic form.
So I just take 1 out of everything.
Yes.
That's all you had.
That's what we have to do.
Thank you. What multiplies to 12 but adds to 7? Same signs.
5 and
13.
75.
Yeah.
No, God, no.
Oh my gosh. Multiplies to 12 adds to 7. Same
4 and
signs.
3,
4 and 3.
Doesn't it matter?
No.
So it'll be
Doesn't
x
matter.
squared,
X squared.
3. X squared,
Yep.
4.
Okay. Wait.
So it'll be 2x.
X squared minus 3. Is it factored completely?
Yeah, so
No, you
I-
got your
I-
x
I-
plus
yeah.
2, x minus 2.
That's right, Brady.
Yeah, yeah. I can't do that 3 though,
You can't. Why, Bryce?
because you can't divide that.
It's not a perfect square. You're right.
Watch out, Bryce.
So at this point, is it factored completely?
Don't go no further, you just sit right there, honey, don't move. Yeah. That's easy.
So 2x equals 0, x squared minus 3 equals 0, x minus 2 equals 0, and x plus 2
I
equals
thought they
0.
had to get rid of that x squared.
Shoot.
I ain't even wanna know what. the-
We're going to solve. We're going to get rid of it when we solve. When we divide by 2 here, we get 0. This is going to be 2 steps.
Yeah, you do.
If x squared equals 3, what does x equal?
3,
Nine.
You get F by itself.
How you get rid of a square? Square root it.
Square. There you go, yeah, I see.
But remember, you need a plus or a minus here.
Where is it gonna keep on going?
Where-
X by itself.
Yep, keep on going until you get x by itself. We factor completely, so it's easiest for us as we go.
So it'll be x equals 0. X equals 3. X equals 2. X equals negative. Alright, one more and then we understand.
All right, this one's gonna, y'all stay with me on this one.
The thing's gonna be a song.
Where's the part where you saw me at the bottom?
Do I?
Okay.
Let's say I had something that looked like,
You said we had a last one?
well, homework.
No homework, right?
Wait,
216. With 216, that's 6.
Actually, yeah.
Why do I write all this and then you erase it? Watch, you know, that same problem she had.
I think I want to stop right here. In the bottom